So this is a review of the Pythagorean theorem, and then we're going to amp it up just a little bit by using numbers that we've been studying, using radicals like we've been studying. So remember Pythagorean theorem. The Pythagorean theorem is used when you have a right triangle where you have a hypotenuse is the longest side that's across from the 90-degree angle. It's the longest side of the triangle across from that right angle. And then each of the other two sides is called the leg. Okay, the legs form that L shape. So leg and L kind of help you remember which ones are which. The legs touch the 90-degree angles. Okay. Notice that A and B are your legs and C is your hypotenuse. So Pythagorean theorem is A squared plus B squared is equal to C squared, where C is always the hypotenuse. Okay, the sum of the square of the hypotenuse, C, is equal to the sum of the squares of the two legs, A squared plus B squared. So there are some triples, and so some of you may be familiar with them that always show up. They're nice because you can use them as shortcuts, but if you don't remember them, then it's not very helpful. But here are the triples: 3, 4, 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. Those are your Pythagorean triples. So for instance, if you look at number 1, you notice that the hypotenuse is 13 and one of the legs is 5. If you recognize triples, then you would immediately know that x is equal to 12, because that is a 5, 12, 13. If each of these, if you have a hypotenuse and then one of the legs or any piece, or you have two of any of those three, as long as you can't have 4 on the hypotenuse, right? It has to be these two. Oh my goodness. Sorry. These two are the legs, and then this is the hypotenuse. Okay. So it has to be that if you have 24 on the hypotenuse, this isn't going to work. So you have, if you recognize that, you could do number 1 with a triple, and you would already know the answer is 12. Now, what if you didn't recognize that? No problem. Do Pythagorean theorem. So you could do x squared plus 5 squared is equal to 13 squared. Now, remember, order of operations says that you do exponents before you add and subtract. So we're going to have x squared plus 25 is equal to 169. Now we need to get x by itself, the x squared by itself. So we're going to subtract 25 from both sides, because x is on the left, and so we need to get all the numbers on the right. So x squared is equal to 144. Now x squared is 144, so I need to undo a square. So remember that square roots are inverses. This is why we've been doing what we were doing. Square roots are inverses of squares, and the square root of 144 is 12. Now, you're going to always leave answers exact. Remember, exact means, for example, 3 root 3. Unless I say approximately. Or around. Okay, I have to say those things in order for you to be able to hit the square root key on your calculator. Unless you just want to test it and see if it's a perfect square, you can do that. Okay, so number 2. So we have, here's our hypotenuse. I like to mark the hypotenuse, that way I keep it straight. So then I've got x squared plus 5 squared is equal to 10 squared. So now you need to do your exponents first. So x squared plus 25 is equal to 100. Feel free to always put me on pause anytime you need to get caught up. Okay, you can also put me on halftime or speed up or whatever you need to do. And if at any point you feel like you know what's going on, put me on pause and go ahead and start working ahead of the problem. And then come back and check. We're going to subtract 25 from both sides because we need to get x squared by itself. So x squared is equal to 75. Okay, if x squared, we got to undo that x squared, so we got to take that square root. So this is what we were doing, right? That square root of 75, we need to simplify it because I didn't say round or I didn't say approximately. So we've got 3 and 25 and 5 and 5. This is where knowing how to do that perfect square method is really nice. We've got our pair. If you remember, we can shortcut some of this. The name of the pair goes outside, which is 5, and the leftovers go inside, which is 3. Or if you need to do it all the way out, then you can do it like we did. Multiply your pairs together, multiply your leftovers together, and then take the square roots of the ones that you can. So your final answer is 5 root 3. So x would be 5 root 3. Okay? So number 3. Here's my hypotenuse. That's my C side. So I have x squared plus 5 squared. There's the sum of my two legs squared. The sum of each of the legs is squared. And then sorry, I'm saying it wrong. You square the legs and then you add them together. That's what you want to do. And then be careful here. It's 5 root 2 and that's all squared. That's what we talked about yesterday too. So we have x squared plus 25. If all else fails, put that in your calculator. 5 root 2, enter, squared, enter, and you get your answer. Okay, so we need to square the 5, that's 25, and we need to square the root 2. That means root 2 times root 2. So if we square the 5, we get 25. If we square the 2, we get the root 2, we get 2. 25 times 2 is 50. So 5 root 2 squared is 50. Subtract 25 from both sides to isolate that x squared. X squared is equal to 25. Now we need to get x by itself, not x squared, just plain old x. The square root of x squared is x. The square root of 25 is 5. So that side has to be 5. Now be careful the way that the triangles are turned, because it's not always the hypotenuse is on the right or the left. In this particular case, find it. It's right across from that 90-degree angle. So this is the hypotenuse. Okay, so we have 2 squared plus 2 root 3 squared is equal to x squared. 2 squared is 4. Now, 2 root 3, so square the 2, you get 4. Square the root 3. Root 3 times root 3 is 3. And 4 times 3 is 12. Again, all else fails, put it on your calculator. 4 plus 12 is 16. That's x squared. Square root both sides. X is equal to 4. Now this one's going to come in more handy later, but I want to point it out now while we're working on it. We've got an isosceles triangle that we talked about in the earlier quarter. And what we know is that if we have an isosceles triangle and an altitude, it's going to cut the base in half. And so what is nice is later on when I'm asking you to find the area of a triangle and we need to know the height, now I have the information to be able to do that. Because the height would be x. This length is 6 from here to here for that little triangle. And so I can use Pythagorean Theorem. The 10 is the hypotenuse, so I have x squared plus 6 squared is equal to 10 squared. Now, some of you might recognize a triple. If you notice that the 10 is a 5 times 2 and the 6 is a 3 times 2, which means that the x must be a 4 times 3. It's a 3, 4, 5 triangle. If you don't recognize that, it's not a problem at all. If what I just said doesn't mean anything to you, then just ignore it. Okay, x squared plus 36. Don't forget to square them before you subtract them. We need to get our x squareds by themselves. So we subtract 36 from both sides. We get an x squared is equal to 64. Square root of both sides, and we get that x is equal to 8. So it's been nice because most of the numbers have come out nice and pretty. Okay, so let's look at some word problems. Now, word problems, notice all words, no pictures. Well, this is geometry. You need to have some pictures. So if we're going to have some pictures, then you got to read the problem and see what it says. So a baseball field is a square. All right, so first thing, square. baseball field. So I'm going to draw it kind of like a baseball field, more like a diamond, which is not actually a shape. Okay, so here I got a square. All my sides are the same. You know what, kind of have an idea what a baseball field looks like. We've got home plate, first, second, third base. Okay, each side of the square is 90 feet. So I like to label everything so I have it as I read it. During a double play, the ball is thrown from third base to first base. So I'm going to throw the ball here. How far is the ball thrown? Well, notice that is directly across, and it forms this little right triangle right here. We like right triangles. Special things happen when we have right triangles. So what that creates is Pythagorean Theorem problem. So I'm going to call this X. That's my hypotenuse. Notice it's across from the right angle of that yellow triangle. So I have 90 squared plus 90 squared is equal to x squared. You can call it whatever you want. I just called it x. That's nothing magical. So 90 squared is 8,100 plus another 8,100. And then 8,100 plus 8,100 is 16,200. And I said, how far is the ball thrown? Round your answer to the nearest tenth. We like rounding our answer because it means we get to hit the square root key and not have to worry about reducing. So the square root of 16,200 is 127.3 to the nearest tenth, one decimal place, feet from first base to third base. That's how far he threw the ball. Okay? So you always want to draw a picture. So we have a 15-foot ladder, okay? I can imagine a ladder leaning against the wall, so I'm going to draw me a little building here with some little ground. I've got a 15-foot ladder. So I'm going to label 15 feet. That's my ladder, leaning against the wall. It says it's placed 5 feet from the bottom of the building. Here's the bottom of the building right here, right? The bottom of the wall. That's the bottom of the building. And you don't have to write in all this stuff. I'm just writing it so that you can see where everything's coming from. So the bottom of my ladder is 5 feet from the bottom of the building. So that's 5 feet. How high up the building will the ladder reach? Well, we know that it could reach 15 feet if you put the bottom of the ladder right at the bottom of the building, but that's not a very safe ladder to climb on, right? So we have to lean the ladder, so we know that our answer has to be less than 15. Whatever it is, it has to be less than 15. So it says to find the exact answer and then find the answer to the nearest foot. So first we're just going to simplify our radicals, then we're going to answer to the nearest foot. So the first thing that we want to do is we want to do Pythagorean theorem. We have a right triangle, because hopefully the building is square and has a right angle. So x squared plus 5 squared is equal to 15 squared. So I have x squared plus 25 is equal to 225. Now, since those numbers are on different sides of the equal sign, we're going to subtract 25 from both sides. We're going to get x squared is equal to 200. Take the square root of both sides, because we want x, not x squared. So first it said to do it the exact answer. So I'm going to just go over here to the side so I have more space and I don't mess up where my problem is. And I have the square root of 200. So it's 2 and 100. Now here's what I notice. I'm going to just stop right there for a second. Notice 100 is a perfect square. So if I then take the square root of 2 and the square root of 100, the square root of 100 is 10. I always write my whole numbers in front. And the square root of 2, we're not going to take the square root of 2 because it's a decimal, so it's 10 root 2. So my exact answer is 10 root 2 feet. Now, that doesn't mean a lot of anything, right? 10 root 2 feet, that doesn't tell you much. But this way, the answer to the nearest foot. So type in 10 square root of 2 on your calculator, and you get 14.14 feet, or 14 feet. Now, if you type in the square root of 200, you also get 14.14. So you can, at that point, you can do it. If I ask you to round, you do not have to simplify it first. You can just type it straight into your calculator. Okay, so 9, about how many feet of fencing are needed to enclose? So think about what that means. That means perimeter. We are going around the fence, okay? The perimeter fence, kind of like on Jurassic Park. So how many feet of fencing are needed to enclose a rectangular garden? I'm going to stop for just a second and draw a rectangular garden. With a 50-foot long side, I don't care which one is 50, I'm just going to put 50 on that side, and a 60-foot long diagonal. So a diagonal goes from one corner to the other, and it is 60 feet long. So I want to know how many feet of fencing. So I want to make my fence go all the way around. So the problem is I need that length right there because the other side will match it because this one is 50 also. So we're going to use half of this rectangle, and we're going to get our right triangle. X squared plus 50 squared equals 60 squared. Now, I know I didn't say it. I should have. I didn't say approximately. I didn't say rounded to the nearest, but this is a real problem. Real world problems need real world answers. So I am going to go ahead and give a real world answer at the end of this instead of a simplified radical. 50 squared is 2,500. 60 squared is 3,600. I need to get them on the same side of the equal sign, so I'm going to subtract. I get x squared is equal to 1,100. Like I said, I'm just going to type it into my calculator. The square root of 1,100 is equal to 33.2 feet. Now, be careful. That does not answer the question. That means this is 33.2 feet. That's not what I asked for. I asked for the distance all the way around. So if I add up, then I need to take 50 plus 50 plus 33.2 plus 33.2. 2. So I've got 50 and 50 is 100. 33 and 33 is 66. So I have 166.4 feet of fencing. That's how much feet I need. Approximately, because there were a lot of decimals I cut off. Okay, this last one's just a little bit of a bonus question. So we have a square park with a diagonal from corner to corner. Okay, if the walkway is 38 yards long, what is the approximate length of each side of the park? So this is what I want to know. Now we know that all the sides are the same length because it says that it's a square park. Now I'm going to show you a way that you can do this later that would be a shortcut for this. But since we don't have that yet and we're doing everything with right triangles, we know that right triangles, when we have enough information, we can use our sides and use Pythagorean Theorem. So this side is also x. So here's the trick to this. You have x squared plus x squared is equal to 38 squared. Now normally we would have a hard time with it, but since it's a square, we know those two sides are both x. Well, x squared plus x squared, 1x squared plus 1x squared is 2x squared. 2x squared is equal to 38 squared, which is 1,444. Now I need to get the x squared by itself. 2 times x squared. So it's 2 times. We undo times. We inverse times with division. So the 2's cancel out. Leaves me with x squared is equal to 722. And now I square root from both sides. It does say that I'm doing approximate, which is good because that's nice with big numbers. So the square root of 722 is 26.87, or approximately 27 feet, or not feet, yards. You can know kind of whether you did it a little bit right or wrong, at least have an idea about the reasonableness of your answer, because it has to be shorter than 38. So if you got a number that was bigger than 38, something is wrong, because the hypotenuse is always the longest side of the right triangle. Okay, so when you have a right triangle and you have two sides, okay, so that's important. When you have a right triangle and you're given two sides, that means you're going to use Pythagorean theorem. Okay, a right triangle and two sides. When you're looking for the third side, that means you're going to use Pythagorean theorem.